안녕하세요.
Good morning, good afternoon, and good evening. I'm Kang Hee-jin from CRISO. I'm a senior director of the CRISO Center. Today, I'd like to talk about how to develop green ships and how to develop international standards to reduce the cost of development and to reduce the burden. And I'd like to suggest to build the offshore testbed. IMO has set an ambitious target. It is trying to reduce greenhouse gas emission from ships by 50% by 2050. If you assume the life cycle of a ship is 25 years, you can see each ship has to reduce more than 70% of its greenhouse gas emission to meet this goal. So in recent years, we have new regulations in place to reduce greenhouse gas emission. For example, EEXI came into effect and it will be applied to ships in the near future. This means ships that cannot meet these environmental targets cannot be built or cannot be operated. And major shipbuilding countries and shipping countries have been taking these environmental regulations very seriously, and they are trying to develop these green technologies because these technologies may decide the fate of the shipping industry in their countries. IMO has set an environmental regulation roadmap. Each suggests a short-term, mid-term, and long-term plan. According to the plan, we are kind of late in terms of development of green shipping technologies. The regulations that are applied to existing ships are facing us, and many technologies have been developed and applied. And retrofit of engines and fuel or alternative fuel use and renewable energy sources. They are the options. And CO2 capture technologies have drawn attention, but we have to make sure they are reliable and safe when they are applied on ships. So we need very objective data on these new technologies. And we have to also think about how economically, how these new technologies are economically feasible. They will decide how well they will receive in the market. And CRISO, my organization, and many organizations in countries have spent the past 10 years in enhancing shipping operation efficiency. One of the good examples is to lower the speed of a ship to increase its economic feasibility and to optimize a route, or to apply trim by bow and trim by stern. Another option is to retrofit the hull in a more slick way or apply air lubrication system. And so many countries and many organizations have been developing ESDs and other systems. You have seen LNG power ships in recent years and ships that are partly powered by battery in the market. But despite these efforts, they can reduce up to 20% of greenhouse gas emission compared to the current level. As a result, the IMO is discussing this target of 50% of a reduction by 2050. To achieve this target, the shipping companies may have to choose alternative fuels and have to change their propulsion system. So we need a paradigm shift here. It is important to note that batteries and fuel cells and new renewable energy sources, they cannot be applied to large vessels right away. Technically, it may not be possible at this stage. So in Korea and other major countries, they are applied to small vessels first, and they are tested at real sea and tested from operational perspective so that their performance and reliability and safety can be verified. It is also important to note that the green shipping technologies and ship technologies are applied to small vessels first and rolled out to large vessels. And this means we can develop the small vessel market and the large vessel market all together at the same time. Let's take a closer look at the technical perspective. Vehicles inland require less power than ships. So vehicles can be powered by fuel cells and batteries relatively easily and faster compared to ships. Our option or solution is to use a mix of fuels such as a fossil fuel and ICE to maintain economic feasibility. But in this process, we have to consider the zero carbon renewable sources such as hydrogen and ammonia, and we also have to develop a post-treatment technology, a new fuel supply system and combustion system. Regarding fuel storage, hydrogen has a lower storage density compared to fossil fuel. It requires less space and it requires more space, maybe 8 times more space when it comes to a fuel tank. And if you want to liquefy hydrogen, it is very difficult to do that now because LNG can be liquefied at minus 162 degrees Celsius and hydrogen can be liquefied at minus 253 degrees Celsius. And carbon still has the volatility issue and ammonia has the toxicity and corrosion issue. So these energy resources, new renewable sources cannot be used right away. So the biggest change can come from the shift from the mechanic propulsion system to electric propulsion system. The traditional mechanical system is using piston movement, so the kinetic energy can be used for propeller and it can produce energy. But in this paradigm shift, we can use fuel cells or batteries or renewable energies or such as solar power and wind power. In this process, a new system called electric propulsion is expected to expand. The electronic propulsion system, when it is applied, it is very important to figure out where the engine is located because the propulsion power, the battery of the propulsion power, and the fuel cell location will be different. So the shape of a ship will go through a transformation. This means up until now, we have discussed whether we are going to use zero carbon fuel as a power source for ships, but in the next phase, we will have to discuss what we need to do, what technology we need to develop to change the propulsion system. So we need to take a very comprehensive approach to developing new technologies that will enhance the operational efficiency of ships. Let's talk about the cycle of technology development. We are talking about a wide range of propulsion power system and propulsion system. If to make them be commercialized in the market, we need to come up with regulatory framework first, and we also need international standards for them. And we also need objective data to verify the new technologies' safety and reliability. And for that, we can build sea verification testbed, which means we can use an actual ship to test and verify the new technologies' reliability and performance and safety. IMO commissioned Ricardo to research how much it'll take to develop green ships to respond to new environmental regulation. The result was it'll take 12 trillion won to respond to the new environmental regulation. And 70% of the new technologies need to go through the performance, reliability, and safety verification. So it is very important to do the real sea test and track record
2017년서부터 다양
establishment.
해상선박을
And for
지정하고
these reasons,
있고
Europe has been
세계적으로는
developing new green shipping technologies, and they've been applied to small vessels first. And Europe has accumulated the results and data, and the data can be used to decide the type approval standards and efforts to improve regulatory frameworks at the national level, and it can also be used to establish international standards. But it takes more than 3 years to design this test bed, and it will cost as much as a billions of won, tens of billions of won. And the same trend is witnessed in Korea as well. The picture shows large capacity battery can be transported by truck, and in this process we are using mobile sockets, and this is transported to car Paris. In Korea, this new type of small capillary is being developed. It'll take more than 3 years to develop this, and it'll cost more than billions of won. And this capillary will be used as a substantiation vessel. This cost and development period can be a huge burden on ship owners. So how we can reduce the burden will decide how we are going to develop green shipping technologies relatively easily, and how we can commercialize them and launch them in the market. The Korean government and CRISO shares this common awareness, and they are working together to develop new green technologies and test them. And these efforts are called K Greenship Testbed. A megawatt grade fuel cell and battery and mixed engines will be tested and verified at a real sea. And from this verification process, we will obtain track record. And we will also test and verify many propulsion system, inverter, converter, and propulsion control system. This is the general arrangement of the K Greenship testbed. As you can see in the layout, it is similar to making Lego blocks, build something with Lego blocks. By operating a ship, we can test performance, reliability, and safety of a ship here. The reason we build this testbed offshore is that we want to assist R&D efforts of organizations, but we also want to support IMO. So we would like to work with the IMO, IRB, and we want to use this testbed, offshore testbed, as a key platform for joint research. By building this testbed, the international community can develop technologies together and accumulate data together, and the data can be used for international standards. And this can be discussed at the IMO. And the new green shipping technologies can be transferred to developing countries to help them. And we can also train and educate the talent in the shipping industry on the new green technologies. Development of the new technologies will be used for small vessels first and then expanded to large vessels. And as I said earlier, this will facilitate the development of the small vessel market and the large vessel market. But this should come with new regulatory framework. But again, the testbed, Grinship, can play a big role in accumulating data on performance, reliability, and safety of the new technologies. The Korean government and CRISO will support the IMO to achieve the shipping carbon neutrality. And the Korean government and CRISO will continue to submit relevant reports and documentations to the IMO. So I'd like to ask for your support in the future as well. This will conclude my presentation. Thank you for listening.